Okay, so I think you can kind of see the setup here. It's a little tricky to get this all in one shot. So I've got, so here's our pulley set up, right, with our LED and our photo transistor. I've put our usual function generator here, and then just an oscilloscope to monitor the function generator like I like to do. And now I've also brought in the computer that we're going to use for data acquisition. I have that connected by this cable to our USB interface. So the first thing I think we're going to try to do is to see whether this thing works as expected. And I know I'll try to just narrate everything I'm doing because there's probably only a limited amount that you can see on the camera. So the first thing I wanted to do is to just see, is my computer, is this computer interface counting correctly? We already saw last time that, right, the flip-flops are counting as we expect. The flip-flop is dividing by 2 as we expect, but we haven't tested this computer interface. So the way this works is the following. There's this computer program, Get120 timer, that a student a bunch of years ago wrote. And the way this program works is that it'll record data for 4 seconds and save it to a text file, and then it'll start doing that when I press enter. So the first thing that I just want to look at is, well, what's going to happen if if I just sort of spin the wheel and let it sort of come to rest. So let's see. Let's say that I have reasonable numbers here. I'm going to set this to 1 kilohertz. That's a value we did before. Let's see. I'm going to, whoops. And I've set my oscilloscope to be 500 microseconds per division, so 1 period is 2 boxes horizontally, or 1 millisecond as I expect. So I've got 1.0 kilohertz there, checking out on the scope. So I've got this ready, and let's just make sure we start off. Yep, so we start off, I'm going to start by clearing my flip-flop by pressing this push button. So I'm going to hit enter, and then I'm going to give the wheel a flick, and then it'll start counting on the first rising edge. The circuit will start counting on the first rising edge it sees, and then count for 4 seconds. So I'm going to press enter with this hand, and then spin the wheel, the pulley with this hand, and I'm pressing enter now and spinning, and letting that wind down, and it's stopped taking data. Okay, so I don't know how well you probably can't read the screen, and I'm not going to drag it too close for fear of ripping cables out, but I think you can maybe see where it says here, right, it said taking data, read 38 data points, writing data successfully written to file, enter program, press enter to quit. So I'll hit enter now. And we have this data file, output.txt. And so it's just a bunch of numbers in a text file. I'm gonna I'll read you the first couple. So 0, 35, 21, 21, 22, 22, 23. We can see that the numbers sort of gradually increase. And I'm going to post this file to Sakai so that you can see what's going on and try to think about whether the result might be plausible. So I'm going to go and rename this file. This rather rudimentary program always saves to output.txt, and if you don't rename the files, it'll just overwrite the last run. So I'm going to rename this. So KF0415. So let's just call this pulley free spin 1 kilohertz dot txt. So I'll save that file and then I'll post this to Sakai. At this point, I would propose you pause the video and open up that file, take a look at it, and see if the results are plausible. And in particular, why are the counts increasing as the file goes on? So other than maybe something funny happening right at the very beginning as I'm maybe still spinning up the pulley, the reason that sort of for the bulk of the data the counts are going up is that the pulley is slowing down due to friction. What we're counting here is the number of counts of the master clock between for every 1/3, as the pulley rotates by 1/3 of a rotation, and right, we're measuring that every 2/3 of a rotation. So, right, what we have is that as the pulley slows down, it takes longer to rotate 1/3 of a rotation, and so the number of counts increases. So I had just sort of done something like this where I gave the pulley wheel a flick. And you can see from looking at that data file that most of my counts are in the are in the 20s. The last one was the last data point is 131. I'll let you at this point pause the video again, take a moment to think about whether 1 kilohertz is a good frequency to use maybe for this kind of measurement, and if it is, why? If not, why not? And what some of the considerations we might need to consider when choosing the clock frequency are. So as you think about the clock frequency, right, so what we know, right, is that there's roughly a 1 count uncertainty in the total number of counts that I have. Our goal is generally to get the most precise data we can. But there's also a danger, as I encountered in the pendulum experiment, that if we overflow the counter, we're in trouble, especially if we can't sort of obviously say that we're off by 4096, which might be hard to do with a really rapidly rotating pulley, with a slowly rotating pulley, like we did for the pendulum. So we do need to be careful of that. Now, figuring out sort of order of magnitude is a little bit tricky, right? So I was just at 1 kilohertz, and all my counts were just still in the tens for the most part. That probably means we can safely increase the clock frequency by an order of magnitude to give us counts maybe in the hundreds, which will be much better for precision. So maybe let's try and do that and just see if, sort of qualitatively see if the behavior makes sense. So I'm going to change this frequency to 10 kilohertz. You can see that the oscilloscope display has gotten a lot narrower. If I turn the dial here, and we are now at 100 microseconds per division, which is in fact what it should be for a 10 kilohertz signal. So that's a 10 to the 4 hertz. So let's just do another. Let's actually do the same thing again. I'll flick the pulley wheel, and I know I can't flick it exactly the same way, but we can try this. So I fired up the program. I'm going to clear my push. I'm going to get this to be slow. I'm clearing my timer, and then so what I'll do is I'll hit enter with one hand and flick the pulley with the other. So enter, flick. Okay, and it took 34 data points. And so let me open up that file. Great. So now that I'm looking at output, and I'll post this file as well, this is, now I'm seeing counts in the hundreds. Yeah, but again, it looks like aside from the first data point or two, the number of counts seems to be increasing. So let's save this as pulley free spin 10 kilohertz dot text. Okay, so again, hopefully, so you can look at that and hopefully convince yourself that this is working. The counts are still mostly in the hundreds, so maybe we can at least take this as an initial trial and then just see what happens. Right? The concern about there's sort of two limits, right? So if the pulley is rotating really fast, we're going to get very few counts, and so we want a big enough clock frequency to handle that. But if at the beginning, right, the pulley will be rotating slowly, and we don't want to overflow to if we can avoid it. So that'll be sort of be a balancing act. But let's just start with 10 kilohertz and see what happens. At this point, what I'm going to do is let's actually try this with the setup that we want to do. So I'm going to try to do an initial trial. I have my mass on a thing here. So I know you've been thinking about what minimum mass to use. Let's not think of this as like data, but just as a preliminary check. So I'm just going to use a small one, even though that might be smaller than what we ultimately want to use, just to keep things simple. So I have a 20 gram mass here, and this hanger, I don't know if you can see it stamped on the slide, it's supposed to be 5 grams. We can check that with the balance probably next week, but I'll just spread this sort of now 20 plus 5 gram, so a 25 gram object here. And let's see if I can wind this around. I wind the spring around the pulley. And let's see, this is something that might be easier for you to do in lab. What if you had a partner? And I'm going to try to, where's the other end of the string? Oh goodness, okay, here we go. And I'm trying to keep a little bit of tension in the spring to help it wind. And tuck this end into the yoke here, oops. So I can tuck that securely there. Oops. Okay. Alright, so I've got my string being wound up here. Something like that. Wind this mass all the way to the top. Or near the top. I'm going to start with this open. I'm going to clear my flip-flop. So what I'm going to do now so we're at 10 kilohertz, I have 25 kilograms on the hanger. I'm going to fire up the program. Flip-flop is cleared. And then I'm just going to press enter with my right hand to start the timer, and then I'm going to let the mass go. So, and enter, let go. And you can see that this pulley spins down for a while. We took 81 data points and wrote the file successfully. So that's good. So other than something interesting at the beginning, we'll have to think about exactly what all these data mean, but that's something for you to think about. So I'll just save this now as, so I'll put the date on it. Today is April 15th. I'll call this 0415, 25 grams, 10 kilohertz, trial 01, not TXT. Okay. One thing you might be curious about is just how repeatable this is and whether you get different trends. So One thing that's always worth doing is doing this a couple of times. Since this was just the first time we've done it, I'm going to take maybe 2 or 3 runs under the same conditions. And I'll post all the files so that you can look at them. So let me rewind. I'll reset up this here. Maybe I'll just edit out me trying to fiddle with the pulley, and then I'll see you right back. Okay, and we're ready to take another run. So my foot block has been cleared. I've fired up the program. So I'll hit enter with my right hand and then let this thing go. And hitting enter now and release. And we got 89 data points. So let me open this file and I'll save it again. Save as, and we'll call this 0415, 25 grams, 10 kilohertz, trial 02. And I'll do this one more time just so that you can, and I'll just share the result so that you can see what happens when we do this a couple of times for consistency. So what I'm going to do now is to repeat that same thing at a couple of other clock frequencies, just so that we can have maybe some sense of what to pick. So let me first start by cranking my clock frequency from 10 kilohertz to 20 kilohertz. And we see now that, yep, so I have my period is 50 microseconds. So we'll see what effect that has. And again, I'll just cut and post the data so that you don't have to see. I'll show you the Boolean the release, but I'll edit out me fumbling with the string. Alright, and we're ready here. The clock is at 20 kilohertz. The mass on the hanger is, we have a total mass of still 25 grams. So I'm going to hit, and I'm going to hit enter and let go. So hitting enter now. And we have 89 data points. And I will save this file. File save as. We'll save this file as 0415, 25 grams, 20 kilohertz. .txt. Okay, so let's do the same thing again for 40 kilohertz, and I'll just show you the data for this. So there's one last thing I want to do today, which is, and then you'll have a lot of data to go and look at and see if you can get it, start to do some analysis using, say, Excel. But the last thing I want to do is just to confirm that this is working, and that we can maybe see a difference in the angular acceleration of the pulley if we use a different mass. So now I have here a 100 gram mass, and I'll stick that onto my hanger to make 105 grams. I'm starting to worry about smashing up the floor, so I am going to go grab a pillow from the couch and put it right here. I'll be right back. So I'm back. I don't know if you can see it, but I just took a pillow from the couch and stuck it on the floor, and let's see if this works. So I've got my 105 grams here. Let's wind it up onto our pulley, and then I've set the clock to be 20 kilohertz this time. So in the middle of what we were trying. I think this will give us enough information to sort of make some decisions about how we should do the experiment, and I really want to hear from you. So please use the Sakai forum for this class to give me some thoughts on how you would like me to go and take data. So I've got my pulley all wound up here. My clock is at 20 kilohertz. I'm about to fire up this get120 timer data.exe program. And so we're ready now. And so when I'll hit enter, and then I'm gonna let this thing go. Let's see what happens. Hitting enter now. And we took 101 data points. So let's save that file. Save as. We'll save that as 0415. This is 105 grams at 20 kilohertz. .txt. Alright, so I think that's plenty of data for you to be looking at to try to understand what's going on in the files, and to give you some, and to have some thoughts now about what we're going to do as we go and actually try to take data.